All right, here we are going to sketch a polar graph, which is called a cardioid, and we'll see why. We have r equals 1 sine theta. Now, there's different approaches. The approach I'm going to take, which we can decide whether we want to continue with or keep doing, is I am going to sketch r equals 1 minus sine theta on the r or the theta r plane. And some people don't really care for this. I think it's a good way to do it. Now, when we see this r equals 1 minus sine theta, this part 1 here is a shift up. That is going to be a shift up by 1. And what I'm going to do is I'm going to draw a dotted line, which is the line r equals 1. And let's see where that goes. Okay. Now, the period of this function is 2 pi. And when I divide that by 4, I get 2 pi divided by 4, which is pi over 2. And I'm going to use that to find my key points. I am going to work this out so that the horizontal and the vertical axis don't have the same scale. It's just a little bit of trouble if I do that, so I'm not going to worry about that. So I have 0, and then I add a fourth of the period, which gives me pi over 2. Another fourth, which gives me 2 halves, which is pi. Another pi over 2 gives 3 halves, and then I get 4 halves, which is 2 pi. Okay, now back to our curve. I am going to treat this line r equals 1 as the horizontal axis. And so the whole thing has been shifted up by 1. All right, so I'm going to draw negative sine theta, which is the sine curve reflected around a horizontal. And so let's go ahead and do that. So it's going to look like this. I feel like I was too nervous or something to get a nice smooth curve. It should be really smooth looking. Okay. But I mean, it really doesn't have to be perfect. This is a reference. All right, then what I'm going to do here is show you another approach, which maybe some people would use without even making this little table, is that I just plot points for this function. R is a function of theta, and see when, according to this graph, when theta is equal to 0, r is equal to 1. When theta is pi over 2, r is 0. When theta is pi, r is 1. Theta 3 halves pi, r is 2. Theta is 2 pi, r is 1. Okay, but the idea actually is that we're supposed to be able to sketch this curve really quickly, and we can then use it as a reference. It's not supposed to be that we get really stuck on this curve. That's that's supposed to be sort of the easy part, and then we do the polar curve from that. We're already supposed to be sort of masters of the graph already that we have above. Okay, now let's check this out. All right, so I am going to label theta equals 0, theta equals pi over 2. I don't even know if I need to write theta. I think it's sort of get the whole idea what that is. Theta equals 3 halves pi, and then this is also 2 pi. Okay, so I'm going to then plot points. I have to figure out what my scales should be, and I want to make this a little longer to get this to work. And then also I might end up erasing some of these labels because they might get in the way. I'm going to pick a nice bright color, maybe this orange color here. When theta is 0, r is 1, I'm going to choose this that distance to be 1. So it's a distance of 1 from the pole. And then pi over 2, we get 0. And what it's going to look like is something like this. I'm not saying it looks exactly like this. To get the exact, we need to take out a computer, or look it up in a book where someone already used a computer. At pi, when theta is pi, r is 1. R is the distance from the pole. It's the distance from the pole. So the distance between the pole, which is also the origin, and the point that I've just shown is 1. It's a distance of 1. Now, how do I know it makes this little smooth curve? Well, we could plot more points, but especially a computer would do that. So it's a little bit like, yeah, I believe it's true because the computer says so. But we would plot more points. And then at 3/2 pi, that's a distance 2 from the pole. And I'm going to try to make it look nice and smooth because I've seen pictures of this and it looks sort of like a circle, really. And then I don't want this here anymore because I don't want it to ruin the picture. So it's really a little bit of an art project, and some people really like it, and some people it's not their favorite thing to do here. But I think it's really fun. This is then r equals 1 minus sine theta. It is a cardioid, and we can sort of see, well, why is it a cardioid? Well, looks like a heart. So you could send that out for Valentine's Day if you wanted. And that's everything there. Hi, well, I just thought I'd add on to the video that this is a computer-generated graph of r equals 1 minus sine theta. So the one I drew looks similar, but this one's better. And, I think that it's good to use technology sometimes to see what it actually looks like. Okay, so that's all.